and welcome to What Matters. My name is KJ. Hope you guys are having a great day today. And right now, as you know, every Wednesday we go on to What Matters. And in What Matters, we talk about things that are important to us. And today we're going to be talking to a senior technical lead test engineer in the RF industry. RF stands for radio frequency. Now, RF makes the world go round. So the topic today is engineering a wireless world. And joining us today is Dina Garan Salvadure. Hello and good morning, Dina. How are you today?
Hi, Karthik. I'm fine. Thanks for having me in TRAXXfm.
All right, man. All right. So I know you are based in Pulau Pinang. So unfortunately, you are not in the studio today. So, but thankfully, we have radios, and you have your phone, which is also running on RF technology, and we can talk over vast distances.
Yeah, exactly. So, yeah, because of the advancement.
Of the advancement, yeah, exactly. Right. So before we get on further, I'd just like to ask you, for our listeners out there, can you just explain, for those of them hearing about RF engineering for the first time, right? How would you describe what it is, and where do we encounter it in our everyday lives?
So when we talk about RF engineering, right, so it's basically, we are going to talk about radio frequency technology. So very simple thing, right? So when we are tuning in into a radio, we always like tune into a 92.7 or 96.3. All of those are the radio frequencies. Right?
Mm-hmm.
So that is the basic example of radio frequency. We are tuning into a radio, and then we can see some frequencies, right? So those are RF frequencies. Besides that, before the era of smartphone, people can either only call or send text messages, right? But now we are using WhatsApp to send images, videos, and everything, right? So this is only possible with the evolution of the RF engineering. So we are actually evolving into something greater. So that is basically RF engineering means, yeah.
All right, but RF engineering is also now much more advanced, as you say it is, but we will be looking at that much further down the road during our interview today. But you are a senior technical lead, you're a test engineer, and of course today we are also talking about the career path that takes you to become a senior technical lead test engineer. It's a very long title, by the way, but I would just like to ask you, as a senior technical lead, you guide, this is what they say, you guide cross-functional teams on new test programs for mass production. What does that process actually look like from start to finish?
Okay, so when we talk about engineering itself, right, it has a lot of branches. So when we say we are working with the cross-functional teams, so we're going to work with the design guys, product guys, process guys, and also test guys, right? So basically, let's just think that I'm coming up with a new design, right? So to make that design to work, we need a process. So that's where the process guys step in. Okay, so once the process guys complete the process and the product is there, then the product guys step in. And when you want to have the product, you have to make sure that it meets the customer requirements, right? So how are we going to do that? We're going to do the test. So that's where our team steps in. So we have to work cross-functional across this team to actually release the product to the customer. So that's what we are saying, that we are working with the cross-functional team from the test program to the mass production, right? So test program development will be our team, but the designers will design the product, and the process guys will make the product, and the product guys will evaluate the requirement of the product.
All right. Okay, so I understand that is a lot. By the way, are you on speaker?
No, I'm on a call, not on the speaker.
Okay. Because we had a sudden drop in quality over there for a moment, but yeah. Your job is vast, it's wide, because you need to be able to understand the hardware aspect, the software aspect, as well as the user interface, the human aspect of it. It sounds very daunting. How do you like your job?
Actually, it's pretty interesting, but at the same time, it's there's a lot of troubleshooting. It's a draining also.
There's a lot of brain usage, lah.
Yeah.
All right. Okay, now moving on to the next question, Dina. When an RF design, right, because as you said, it starts from the designers and then it moves through multiple steps, then comes to you guys, right? When it starts moving from prototyping to mass production, what are some of the biggest technical challenges that you and your team of engineers have to solve?
Okay, so when we are testing semiconductor chips, right, to make them, it's not an easy process. It's like if you want to bake a cake, right, you have a certain process. It's the same thing we can implement into the RF design. Like we are going to come up with a new chip. So the process is 100% process efficient.
Mm-hmm.
So if your process is efficient 100%, you don't need to do a test, right? Because you know there is no process issues, so the product will be good.
Yeah,
There
no
is
room
no
for failure.
yeah,
Mm-hmm.
so that is not possible. So when the process is getting sophisticated and complex, you might see some abnormal behaviors that we need to root cause. That's a very big challenge.
Mm-hmm. Mm-hmm.
Yeah, so that is one of the biggest challenge, like root causing the problem, doing debug. A lot of time needed. Yeah.
And then you will rotate again to the designer, then comes back to you, rotate back, comes back to you. And that
Yeah.
and that explains why sometimes certain technologies take such a long time to actually reach like markets or commercial applications, right?
Yeah, exactly. So some development might be on the pre-stage.
Mm-hmm.
You might not know. It will take like 4 years, 5 years, and suddenly it comes out, right? But we engineers, we might know earlier. Like for example, the EV chips, right? To actually to come up with electronic vehicle chips, it will take 4 years.
Mm-hmm.
Mm.
All right. Okay. So some of the world's most hidden answers you can ask engineers lah.
Yeah. Actually, what is the next technology and all that? Yeah.
Okay, I'm going to call you one of these days and ask you where can I put some money into technological stocks. I think you know exactly where the world is evolving to. All right. So Dina, your position as a technical lead, it differs, right, from a designer or a test engineer, right? So what kind of leadership skills come into play? Because you're not only dealing with the machines, you're also dealing with human. How do you work this out?
Okay, so basically, technically, we have to lead the test engineers, right? So what we do, like we have a greater experience compared to the new test engineers, right?
Mm-hmm.
Because they are less experienced. So whenever they encounter some issues that they couldn't solve, they bump into issues, they don't know, they have tried all the possible solutions, they don't know what to do next.
Mm-hmm.
So they come to us. So we, as a technical lead, need to guide them because we have experience. So we might have encountered this earlier. So we need to give them solution. We need to provide them what to do and guide them and give them some understanding on why they are seeing this and all that, right? So our main primary focus should be guiding them and making them become better.
All right. So essentially, what you're trying to say is that sometimes what's not in the knowledge base that the test engineers all refer to is in the senior technical leads and their senior engineers. They might have encountered the problem before, and it's more of a human thing rather than just looking in a book.
Yes, exactly.
Mm-hmm.
Yeah. Something, yeah.
Okay. How about tools, right? Because this is a very highly advanced industry. What kind of software, equipment, or testing systems are essential in your line of work?
So when we say tools, right, we call it automated test equipment. So these equipments are automated to test the semiconductor chips. So what happened? They have all these signals that they need to source. All those measurement equipments will be all placed into one equipment. So they call it ATE. So they have a board. So we are testing chips, right? So we need some handlers to pick and place them. That will be something mechanical. So we pick, place, test it, put it into a board. So you need to power up the board. The power up and the sourcing and the measuring all be done by the ATE. So to control the ATE, we'll have the software.
Okay. All right, Dina, what we're going to do right now, we're going to take a short break. We're going to listen to one song. And once we come back, there is more that we're going to be talking about, right? We'll talk about 5G, Wi-Fi 7, and IoT, which are all brand new things. So don't go anywhere. Just stay on the line, please.
Yeah, for sure.
All right, so we're currently speaking to Dinagaran Silvadurai, who's a senior technical lead test engineer. He works in the RF industry, radio frequency. For those of you who don't know, RF might be invisible, but it's everywhere all around us. And this is what matters. We are talking about engineering a wireless world. Hey there, welcome back. And right now we are back to What Matters. And joining us today via the phone lines all the way from Penang is Dinagaran Salvadore, who's a senior technical lead test engineer. We're talking about engineering in a wireless world. And even right now, you listening to the radio in the car, you are listening to us via RF technology, some of the earliest that we found out about. Welcome back, Dina.
Yes, hi. Hi guys. Yeah.
All right, so Dina, we started off with the phones. We had 1G, 2G, 2.5, 3G, and then 4, and then 5. We are now at 5. We've also got Wi-Fi 7 out. IoT, which is the Internet of Things, also rapidly evolving. How are these new technologies changing the work of RF engineers? What are things that you see on a daily basis now?
It's actually giving us more headache, right?
Okay, more headache, all right.
Yeah, because the work is getting more complex and sophisticated because the technology is evolving, right? So it's giving us more headache. Just last time, when you're talking about 2G, like our legendary phone 3310, right? It operates in a 2G. You can just text or call them using that phone because it's operating at a low bandwidth. Now we are operating at 4G, 5G, which have a wider bandwidth. So when we talk about wider bandwidth, the hardware design will be complex, the test would be complex, and to assess this behavior is actually difficult because when we go to a higher bandwidth, the complexity increases and there are more problems occur. It's going to give us more headache.
And I mean, not only from the testing aspect of it, but also designing it, right?
Yeah. Designing it is also going to be very difficult because the hardware work could be difficult.
Yeah, that is true. And now let's look at the career path to become an RF engineer, because this is a very interesting job choice, a very interesting job scope as well. Because I did have a look at your job description. It is very interesting what you guys do. So let's talk about your educational background or degree. What educational background or degree would you recommend for someone who wants to enter this field? And after that we'll talk about their specific certifications. Maybe start off with the educational background.
So mostly anyone who are getting involved in electrical and electronics, and also electronics and communication engineering, I think they would be the most. If they are on the computer and communication engineering, they also can get into this field. So mostly anything related to communications, electronics. So that's these are the educational background is needed. Someone needs to be passionate on electronic circuits. They need to like it. Right? If they don't like all this, I think they wouldn't like this job.
Yeah, you need to love this, right?
Yeah. Because if you don't like this, then you won't be doing the job. You'll be like, oh, what is this? What am I doing?
That is true. And how about you? What is your education background? What did you study for?
So I studied for computer and communication engineering, and then I did my master's in communication engineering. Yeah.
Wow. So you have a master's. That explains your job title. Yeah. And this is not a job that you can just enter willy-nilly, right? You need to have the educational background.
Yes, you need to have educational background and also some technical expertise because the interviews would be tougher. You're going to have this kind of job. Yeah.
Okay. So that would mean if they've already did their communications as well as computer engineering, they need to be able to prove that during the interview itself.
Yes. It's not like you just memorize things. Like you need to understand how it works.
Okay. And how about certifications? Because, like, for instance, in terms of, say you're doing software engineering, right? You definitely will need to do certifications to stay on top because 3 years is considered obsolete in IT. How about this?
Yeah, we have some certifications. For example, a specific certification for a specific tester. If you're working with this NISTS, they have this LabVIEW. This is a different coding. We call it a GUI programming because it's not a text-based programming. So they have these certifications. So you can take those certifications. That's really going to be helpful because most of the testers are using this kind of complex software tools. Yeah.
So when you talk about certification, this is a question that I wanted to ask you. Can someone in your line, they just grow within the field having only their degree or their master's, or is certification a must?
I mean, certification is not a must, but if they have it, it's good. Because once they have it, they'll have more understandings on how things work. But it is not a must. A degree itself is enough. But the most important thing is they should have passion to work on this electronic circuits.
Yeah, because it is a very technical thing, and not many people can do it. Like, you might study for it, but if you don't love it, this is not the job for you.
Yeah, exactly. Yeah.
All right. Okay. Beyond technical knowledge, what soft skills are important when you like for you? What soft skills are important when you work across multiple teams in such a highly specialized environment?
So when you're going to work in this highly specialized environment, right? So you need to make sure that you articulate the information in a correct manner. So when you want to have a communication with people, like technical people, you need to be precise. You need to have a proper documentation. Make sure everyone on the same page. You don't simply blame people, right? Oh, you're the one at the fault. You're the one who are making it wrong, right? So because later on you're going to work with the same people, so you need to make sure that you handle things in a good manner.
Yeah, have to see their same face, lah.
Yeah.
Right. How about you? Do you think you're a good boss?
I would let my juniors to judge me.
Okay, give me their phone numbers and I'll call them, lah.
Yeah.
All right. So now moving on to the technical aspect again, since we have already looked at the career path growth, RF technology works at an incredibly fine tolerances. How do you and your team maintain reliability, accuracy, even when small variations can cause issues?
Okay, so this is where our product engineers comes in, right? So, so these guys, they are the one who will make sure that the chips that is tested are within the required specification. Okay, so anything goes out of tolerance. We call it outliers. Most statistical guys call it outliers.
Outliers.
Yeah.
All right.
So when they see this kind of behavior, this distribution is getting shifted. So what they do, they'll try to root cause, or is it process, is it test, or equipment? What is making it to happen? Right? They will do the proper analysis. If it because of test, they'll come to us and they'll try to, okay, please fix this, please fix this. So we have to find a way to fix it. Yeah.
All right. Okay, finally, right, we're actually at the end of our interview for today. Finally, as someone who's been in the industry for years, now you've been working for what, about 10 years now?
Yeah, 10 years, exactly.
All right. So what's your outlook on the future of RF engineering? Because we are currently in a very breakneck speed of growth, especially with AI, automation, EV, batteries and all that coming to play. How do you think the world is going to look like in another 5 to 10 years?
We're going to have self-driving cars.
And that also works on RF technology, doesn't it?
Yes, exactly. Like the sensors, there are sensors. The self-driving cars need a lot of sensors.
Yeah,
so
sonar, LiDAR.
Yeah, so that technology, we call it as a vehicular technology. So they need a very complex and advanced sensors to actually to detect, because you're going to have a small changes, you need to work accordingly. So you need to make sure that operate at a very high frequency and a wider bandwidth. And then you see, if you remember, Mark Zuckerberg introduced your lens, Ray-Ban lens that can actually listen to you, translate whatever you are talking, and all this requires it. So all this requires RF technology.
So essentially anything and everything right now, RF technology is involved with it.
Yes.
All right.
AI also. Yeah.
All right. Dina, I think you've opened up my eyes a little bit more for what RF technology and what does it actually do, because we hear radio frequency. Like even right now, I'm on radio because I am on a spectrum, right?
Yes, exactly.
So there is a lot of things that is currently going on. We would love to have you again, but we hopefully once you're in Kuala Lumpur or something like that, maybe we'll have a small talk about this again on air. But right now, I'd just like to say a big thank you to you for taking the time out of your busy schedule to talk to us and tell us more about RF engineering. Thank you so much.
Yeah, thanks a lot, Karthik. Thanks a lot for having me.
All right, you have a good day and we'll see you soon.
Okay, Karthik. Thank you. Bye.
Bye. All right, so that was Dinagar Salvadore, who's a senior technical lead test engineer. We spoke about engineering a wireless world, and yes, RF technology might be invisible, but it's all around you. And 5G, Wi-Fi, wave, all of these are considered RF. Even if you like auto cruise control, right? That runs on RF, and so much more. but there is more to see, especially with such a fast-paced, evolving technology. I absolutely love technology, so this is interesting to me. But with that, it's about time I shut What Matters down, because I'll be back. Well, actually, I won't be back. Anna and MK, they're going to be back. All right? I'll be back maybe sometime soon. All right? Right now, let's get on back with the music. This is Traxx.